Hello everyone and welcome back to our channel. So today we will learn about .NET API availability monitoring using OpenTelemetry, Prometheus and Grafana. So observability tools like OpenTelemetry, Prometheus and Grafana offer powerful solution to monitor performance, track errors and visualize trends. So we will walk you through deploying a .NET Core API to an AWS EC2 instance and integrating it with OpenTelemetry for metrics, Prometheus for collection and Grafana for visualization. So first, let's see the prerequisites. You should have AWS account with Ubuntu 24.04 EC2 instance up and running. Then basic knowledge of .NET, Prometheus and Grafana. So let's move on with the practical. Our first step is install .NET SDK on Ubuntu. So first, let's update and upgrade the package list to ensure you are installing the latest versions. Just wait a minute until it finishes. Now our package list is updated and upgraded successfully. So next we will install a .NET SDK. So let's install it. Now after installing it, let's make it executable. Then next we will install a .NET 9 SDK. This will install the SDK on your home directory. Okay, so now it's installed successfully. Next, let's make the .NET command available globally. So let's add it to the shell's path. Now let's verify the installation by checking the .NET version. So as you can see, our .NET is installed successfully. Now our next step is create and configure .NET Core API. So let's create a new minimal web API project. So our project is created successfully. Let's navigate to it. CD to do API. So now we are inside the to do API directory. Now once we are inside it, we will add the necessary NuGet packages for API, OpenTelemetry and documentation. So let's add these all packages. Okay, so now packages are installed. So next we will create a model files, which is nano todo.cs. Nano is a text editor. So let's copy this code and paste it inside our file. So this code defines the to-do model class in the to-do API namespace. It is used to represent a to-do item with the properties like ID and integer that uniquely identifies the to-do item. Then public string name. This is a nullable string that holds the task name or description. Then is complete here. This is a boolean that indicates whether the task is completed, and secret. This is also a nullable string that might store sensitive or optional information related to the task. So let's save this file. Now next, we will create a database file. tododb.cs. Let's copy this file and paste it inside our. So this code defines the tododb class, which is a database context used by entity framework core. So it inherits the DB context, enabling the interaction with database. The constructor here accepts the DB context operations to do options to configure the context, for example, in memory or SQL database. Then there's DB set to do, to do's. This represents a table of to-do items in the database, allowing the CRUD operations on the to-do model. So let's save this file. Now next we will create a DTO file, to-do item DTO.cs. Let's copy this code and paste it inside it, our file. Okay. So this defines the data transfer object, which is DTO, in a to-do API namespace, as you can see here. It contains only selected properties like ID, name is complete, omitting the sensitive fields like secret, which we have seen in todo.cs file. The parameters constructor is used for serialization here. So let's save this file. Now next, we will create a program. Sorry, we will edit a program.cs file. We will replace the content of this default program.cs file with our API logic, including the OpenTelemetry configuration for metrics and logging. Let's copy this code and paste it inside our file. So here you can see we are using some directives. This imports the necessary namespaces. There is to-do API. This ensures this matches your project's namespace. Make sure to match your own. Then there's OpenTelemetry matrix, logs, then Microsoft extension, logging. system diagnostic metrics, then also OpenTelemetry exporter Prometheus. This is specific using for Prometheus exporter and OpenTelemetry exporter. Then we are building that using wire builder, and there is service configuration written here. Here to do DB is your custom DB context. Then in this whole section, there is OpenTelemetry configuration. Here where app meter, new meter. This defines a meter used for custom matrix tracking if needed. Then there's a registry of OpenTelemetry. Here add ASP netcore instrumentation, tracks the HTTP request duration, status, etc. Then add runtime instrumentation. This tracks the CPU, memory, GC metrics. Then there is also add Prometheus exporter. This exposes metrics in Prometheus format. Then lastly, in Prometheus section, there is logging, add OpenTelemetry. Here this captures logs and writes them to the console. Then there is, we are configuring the Swagger and OpenAI here in this section. This is a Swagger setup. This enables Swagger UI and API documentation generation using NSWag. Then we are building that and configuring the middlewares next. This enables Swagger UI always for testing purpose. Here add use open API, search swagger.json, and there is also UI config. Then next is minimal API route group. Here route group builder to do items in this line. This defines the endpoint under this group. This also handles the follow. These handlers follow the RESTful CRUD operations. There is get all to dos, get complete to dos, then get to do, create to do, update and delete. And next is app.run. Then these are API handler methods. All the methods use typed result for better performance and type safety and are asynchronous. There is, just a minute, get all to dos, which fetches the all item, then get complete to dos. It only fetches the when is complete is set to true. Yeah, as you can see, then is complete is true, then it will fetch the item, getting the complete to do items, as you can see here written. Then get to do ID. This returns the item or 404 if not found first, but you need to enter the ID. We will see it in our app in the practical. Getting to the items by ID. Then there is create to do DTO. This creates a new item. Then update to do. This one updates the existing item, and delete to do deletes the item if found. So let's save this file. Now let's publish the application using .NET publish directly on our instance to create a self-contained deployment. And you need to make sure that you are in to do API directory. Sorry, let me just copy the command again. Now let's paste it again. So as you can see, our to-do API is built successfully. Now our next step is configure as a system service. So let's create a service to run the API. So let's create a to-do API dot service. Let's do this code and paste it inside our file. So this is the systemd service unit file used to run the ASP.NET Core minimal API as a background service. Here, the unit section describes the service purpose, which is description, ASP.NET Core minimal API. Then there is service section. Here, working directory is home Ubuntu to-do API publish. This is the path where the app is published. Then there is exec start. This command to run the .NET API. Then restart is set to always. This will automatically restarts if it crashes. And restart sec set to 10. Then syslog identifier equals to-do API. This is used for logging under the unique name. Then user is Ubuntu. In environment, this sets the environment variable like the environment production and the port 5000. Then install tells the systemd to start the service at boot. So let's save this file. So what this file does, this allows the .NET API to run persistently and restart on failure. Now let's reload the systemd. Enable it. Then let's start the service. Now let's check its status to verify if it's running or not. So as you can see, our to-do API service is active and running properly. Now let's get back to our home directory. Now next step is install and configure Prometheus. So first let's create a Prometheus user. Then we will create the necessary directories. Now let's download the latest Prometheus binary using this command. So the binary is downloaded. Now let's extract it. So now it's extracted. Let's navigate to it first. Now we are inside the extracted Prometheus directory. Next, let me just scroll down. Okay, move it to user local bin directory. So Prometheus binary is moved to user local bin now. Now let's set the ownership for binaries. Sorry. Now let's say the directory. Let's set ownership for the binary. Then we will create and configure the Prometheus.config file. Prometheus config file. So for that, we will create a Prometheus.yaml. Let's copy this code, paste it here. Here, the global scrap interval is set to 15 seconds. And there is also scrap configs where job name is to do API and target is set to localhost 5000. So let's save this file. Now let's set the ownership to the config file also. Then we will create a systemd service for Prometheus. So let's copy this code and paste it here. This will create a Prometheus.service file inside systemd system etc systemd system directory. Copy this code, paste it here. Okay. So this is the systemd service unit file for running Prometheus as a background service. So here is also there is unit section, service section, and install section. And in unit section ensures the Prometheus starts after the network is online. You can see here. And this description is nothing but just Prometheus. And in service, user is set to Prometheus. Group is also Prometheus. This runs the Prometheus as user and group and executes the Prometheus binary here with config file etc Prometheus and Prometheus.yaml and storage ts.tsdb.path is set to var lib Prometheus and web listen address set to 9090 port. This exposes the Prometheus on port 9090. Restart is set to always. And syslog identifier is Prometheus. This logs under the name of Prometheus. Then install ensures the Prometheus starts automatically on boot. So let's save this file. Let's reload the Prometheus. Enable it. After enabling the Prometheus, let's start it. Okay, now Prometheus is started successfully. Now our next step is install and start Grafana. So let's install the dependencies for Grafana. We will install apt transport http software packages common. If it's not installed on your system, you can install it. Now next, let's add the Grafana's GPG key. Let's add it. Then we will add the Grafana API repository. Next, let's update the apt cache before installing the Grafana. Now, next, let's install the Grafana. So Grafana is installed now. Let's enable it first. Then let's start the Grafana server. So now our Grafana is also running. Now our next step is testing the deployed .NET API. So for that, let's navigate to HTTP. Then you need to enter your own EC2 public IP4 address and /swagger. So let's copy it and open it inside our browser. Copy the public IPv4 address and paste it here. So, okay, sorry, I forgot to put the port number here, which is 5000. So after public IP address, colon 5000, then /swagger. So as you can see, our to do API app is selected. Now let's interact with it. We will use a JSON payload to interact with this all API endpoints, which is get, post, then port, delete also. So let's copy this, which has ID set to 1, name walkdog, and its complete is set to true. So let's copy it. In the post, click on try it out and paste it inside the request body. Now once you paste it, click on execute and it will be executed and you will get the 201 response code. Okay. Now let's go to get to do items and try it out. Click on execute. So what it will do, it will return the request body of this one which we have just posted. So let's execute it. So as you can see here, ID 1, name walked and its complete is set to true. And let me show you this quick. Okay, and to do items complete. Click on try it out and execute it, and it will return you the id 1 name walked out. This request body is completed true. Now when we set is complete to false, then it will not this particular get to do items complete will not return the request body. So let's also try it out. So go back to put, try it out in id, click one, and set the is complete to false. Click on execute. Just a minute. So as you can see, it is set to false. Now let's try get again. Let me close this post. Okay. So if you execute get to the items again, it will return the value id1 name walked out and is complete is set to false. Now when you do the same with get to the items complete and execute it, it will return null value because is complete is set to false, and it will only return the true values. And in to the items id get, it's simple. You just need to enter the id number which is 1 and click on execute. Then it will return the value related to that id, sorry, request bodies, and delete. Let's try it out also. Enter the id, execute, and the item will be deleted. So let's try get again. There you go. And now it has returned the null response body because the item is already deleted. So this is our to-do API. Now let's try the error also. Let's just generate it. So it will generate error in our logs or metrics. Now our next step is test the Prometheus deployment. So let's copy this and paste it in browser. Let's copy the public values and paste it here. Then colon and port 9090. It is a default port for Prometheus. So let's run it. So as you can see, this is our Prometheus homepage. Now go to status, target health. So here you can see the to-do API here with the state of. Now let's go back and then go to graph. Here you will enter HTTP server request duration seconds count. Let's run this query here and click on execute. Now here you can see the graph and the request which we have handled. Delete. Then there is get food items complete, then food items ID. There is also post and put request which we have performed in our to-do API here. Okay. Now next, let's test the Grafana deployment. So let's open Grafana. Again, open browser, copy the public IP address and paste it inside the EC2 public IP address. Okay. Then colon port 3000, which is default port for Grafana. Now let's run it. So here you can see the Grafana. Okay. You need to enter the username, which is admin. Password is also admin to log in. Okay. Now first it will ask for setting up the new password, or you can just skip it. So this is the home page of Grafana. So now here from the left sidebar, go to connections, then go to data sources or add data source. Select Prometheus as a data source. Now enter your Prometheus URL here, http:// then copy the public IP address, paste it here, colon, and port 9090. Scroll down, click on save and test. So you should see the message successfully recorded the Prometheus UPI. Now from the top right, go to this plus icon and click on new dashboard. So let's create a dashboard now. Okay. Click on add visualization. Select Prometheus as a data source. So first we will select Gauch as a visualization. Then here we will select code. Okay. Now here we need to enter the from fuel query. So let's copy this first query here. Sorry. Then we will paste it. Now let's run this query. So here you can see it has returned as the HTTP server request bucket. You can generate some error here. Wait for a minute or some time. Then we will push it. Right. So as you can see, once some error is generated, then it is dropped from 100 to 90.5. Or HTTP requests are not done successfully during the error. Now let's save the dashboard. Enter the full title like overall availability. Availability. So dashboard is there. Now let's add another panel in it. So go to add and click on visualization. Now we will select this time table, okay, as a visualization. Now let's copy this query, okay, and paste it here. This query will show the top 10 most requested endpoints like get, post, put, and how many times each was hit. So let's run it. Okay. So there is it. So here let's use the transformation. Go to transformation, click on add transformation, and search for group by. Just a minute. Let's delete it. Let's add a legend first. System. HTTP request. Let's set it to HTTP request method and HTTP root. Let's run the query. Okay. Set this root table. Yeah. And go to transformations. Click on add transformation and search for group by. You can keep the time ignored. Then we will group it by HTTP request method. So you can see the get, post, root, delete, and also its root. So the post requests and root to do items, then get to do items, and also get to the items complete, then put to the items ID, delete, and get to the items ID. Now let's get the values, calculate. You can set it to its for last, first value, mean, max, mean, total count, number of values in response, any difference. So you can even select it to all values. So, okay, let's cut it and set it to just count. Okay. So what the count is, just a minute. It will number of the values in response. So now it's grouped here. This is what our table look like. And it shows the top 10 most requested endpoints and how many times they were hit. Now let's save it. Let's get back to dashboard. So this is our dashboard for overall availability. Now our next step is adding the custom program Grafana. Let's do it. Here, go to settings, go to interface, click on add variable. Here, enter the name in the env, then label name, environment, scroll down, then there's a query type, select label values as your query type, then name label, select env, metric, select, Scroll down. Request duration seconds count. And label filters. Job, select value to do API. Okay. Now scroll down and there is selection options like multi-values. To enable the multi-values to be selected at the same time. New to the drop down. It's just like this. This one is drop down. And you can select the multiple values and allow custom values, or you can select include all option. I will just select it all and in custom value this and it shows the preview of values all. Now let's save the dashboard. Okay. Now let's go back to variables. Now let's add a new variable. Okay. Label name, application name, select query type same, label values, then choose label, choose app, select matrix, we will select the same matrix. Okay. HTTP server, request duration seconds count, and in label filters you can keep it blank. Select options like multi-value and include all options. Click on run query and save dashboard. Now let's settings variable. Now let's add another variable. The name will be routes, HTTP route, label name, then select query type, label values, choose label, scroll down, HTTP route, then select matrix, again the same matrix, HTTP server, request duration seconds count, and label filters, and job, select value to do API. Selection option, multi-value, include all option and allow custom values and custom all values. Now let's run this query and save dashboard. Let's go back to the let's open any panel. This any panel. Click on edit. This is something. The new dropdowns are added, which is environment, application name, and HTTP route. And there is also option you can select all or select to do item, to do items complete, or to do items ID, whichever you want. So this is how you add the custom drop down in your Grafana dashboard. So today we have seen about the .NET API availability monitoring using OpenTelemetry, Prometheus, and Grafana. And with OpenTelemetry, Prometheus, and Grafana, these tools in place, you can gain the full visibility into your .NET API's behavior and availability. Just like this, you can see its for availability. And you can now monitor the live traffic, understand the endpoint users, detect errors early, and ensure the SLA compliances. So that's all for today, guys. Thank you.